Hey there everyone, today's video I'm going to be connecting two fire alarm systems to each other. I'm going to be connecting the fire alarm system in the main house to the separate fire alarm system in this garage building. This building system also protects this generator building as well as this shed over here. Let's take a look at what we're working with here and head into the house first. This here is the fire alarm system in the house. This is a Notifier NFS 320C fire alarm panel. This is a full addressable system that protects the house. I have videos on installing this system, actually an entire series on installing this system. So this is the system in the house. Let's head out and take a look at the system in the garage. And here is the system in the garage. This system is also an addressable system, though this is a different brand of system. Both are Honeywell panels, but this is a Firelight panel versus the Notifier panel in the house. Similar, as they are both addressable systems, though the panel in the house is a little bit more capable, as it can have up to 318 points on the system, versus this one can have 198 points on the system. This can have 99 detectors and 99 modules. The house system can have 159 detectors and 159 modules. So both of these systems are addressable systems. However, they cannot be networked. With what I have here, I am not able to have a networked system, nor do I need a networked system. That brings me to talk about what we are actually doing here. These systems are going to be connected to each other, though they are not going to be connected to each other for full alarm, nor are they going to display exactly what's going on the other system like a network system would, where it gives you full communication between the two systems. Basically, all the information on one system is exactly on the other. You can operate systems from each other. It is basically turning the system into full-on one large system. With network systems, much like what we're doing today, should that network fail, the systems are required to be installed in a way that the life safety functionality of that system is not relying on that network. Basically, if you have this section of a building here and this section of the building here, and that network fails, each section still has to be able to work independently, and should an alarm be caused in this section, it will still need to trigger everything in that building, such as your audio visuals, your different shutdowns, and different sequences of events can't all be run by one panel that is then monitoring separate buildings. You have to have each building having its own system to be able to operate independently of each other. Should that network fail, they will each operate as a local system, if that makes sense. So the way we're going to be doing this is with two monitor modules. This system is going to have an addressable monitor module monitoring the house system, and the house system is going to have an addressable monitor module monitoring this system. So the monitor module is an addressable module just like this one here monitoring the sprinkler flow. The addressable monitor module will turn the data logic that the SLC signaling line circuit has and be able to take a conventional two-wire input like this flow switch here that is just a normally open circuit, and it will monitor that normally open circuit and report back to the panel whatever you have it programmed as. In this case, each one is going to be a supervisory. Now hold on, before you ask why aren't you doing alarm, I'm going to explain that right now. So to begin with, alarm condition is not required. These are completely separate buildings. Should there be an emergency event in either buildings, that does not require the other building to evacuate, as they are completely separate buildings and they don't need an interconnected system. Though, could you have an interconnected system if you wanted? Absolutely. The thing is I don't want that. There's a couple reasons I don't want that. For one, I might want to be doing some work out here and I might set off the fire alarm system, and I don't want the fire alarm system in the house going in full-blown alarm, shutting doors, shutting HVAC down, alerting everyone in the building, making a bunch of noise. That's totally unnecessary. Be more of a pain for doing any testing or demonstrations out here. Another reason, which is one of the biggest ones, is should an alarm occur in either building, that then means both systems have to be silenced and reset. Alarm conditions, no matter what, are always latching conditions. That means just because the monitor module monitoring the other system no longer sees a closed circuit, it's not going to reset. You have to actually reset the panel, which is a huge hassle when you have two fire alarm panels and they are connected together but not in a networked manner. I've worked on systems like that, and I've seen the process of a real emergency occurring and the fire department trying to deal with it. It is a pain. It sucks having systems tied together that aren't properly networked and that don't reset themselves. Not to try and drag this along, but the problem with this is having a latching alarm condition setting off other systems is if you have an alarm originate in, say, system 1 and it sets off system 2, you cannot reset system 1 unless system 2 is reset, or then system 2 will then put system 1 into alarm, and it's kind of like a dog chasing its own tail, if you get what I'm saying. So because of that, if an alarm happened in the house and somebody wanted to silence it and reset it because it was just some smoke from cooking or something like that, that would mean that they would have to come all the way outside, potentially have to disarm this building. Not only they would require fob access just to be able to reset this system, because this one would latch an alarm, and then because this one had gone into alarm, the house would then be seeing this one in alarm. So it would turn into a big mess. So that's why we're going to be doing it supervisory. We're going to be doing a non-latching supervisory, where if the house goes off, it'll put this one into supervisory, but you won't have to shut anything off here. Once the house is reset, this will go all back to normal, and vice versa should this go off. You don't need to do anything in the house. Once this is reset, the house will go back to normal. Now you might be saying, why are you doing this at all? It is still nice to have some means of warning that the other building is an alarm. Just because it's programmed as supervisory doesn't mean we'll necessarily call it supervisory. We will end up giving it custom labels saying house alarm, or from the house alarm, garage alarm. So you will still know what that event is that is actively occurring, and it will still give you a local beeping at either this panel or the house panel, which has an annunciator at the front door. So it will still draw attention to it, just not full on this building is actively in an alarm condition. So as I said, we're going to be installing a monitor module on each system to monitor the other system. So in total for that, you need 4 wires, because we have 2 coming from this system monitoring the house system, and 2 from the house system monitoring this system. It's pretty simple. This is our house fire alarm panel. This is our garage fire alarm panel. Each panel has a set of relays. We have common, normally open, and normally closed. Same here, common, normally open, and normally closed. So each panel will have a set of relays like this. And then each panel will have a monitor module attached to it, which is just taking that addressable data logic and then having terminals on it, which is just like a zone on a conventional panel. Just 2 wires, normally open. When it closes, it activates that module. So the garage system will monitor the house system by going to common and going to normally open. Same with the house system. We'll come down to the garage, common, and normally open. Then we'll put our resistor across, which you could just go across. So of course this means we need to get wire from the house panel to the garage panel, which is a slightly long run, as we have to go from the garage underground in a conduit, up a conduit into the attic, and through the attic down to the first floor. Luckily there is a conduit in the ground, as well as a conduit running up the house into the attic. This conduit currently has 1 Cat 5e cable for internet, which usually you can't run fire alarm in anything else, and that is true. You can't do that. However, for this application, it is okay, because this isn't in a life safety manner. This isn't a crucial connection to actually provide the fire protection of each building. Should this connection be lost or damaged or interfered with, it won't have an effect on the operation of each separate fire alarm system. It is simply a means of connection to be able to show that the other building is in alarm. So because this is going underground about 3 feet in the ground, there is a good chance that conduit is full of water. So because of that, just like the Cat 5e cable that is currently in there, it has to have burial rated insulation. For that reason, we can't use our standard fire alarm cable, as this stuff will disintegrate and turn to mush if it is left in water for a long period of time. So we will be using some of this 18 gauge 8 conductor. We only need 4 conductors, actually 6, because I have another plan with it. So we will end up with 2 conductors extra, which is completely fine. But you can see this has this black, very thick insulation compared to standard fire alarm cable, so this is what we will be using. So luckily, last time when I fished in this data, I left a pull string because I knew future me may want to pull something else through here. Anyways, I've been talking for a while here. I think we should get into the video and start pulling some cable into the house. So since we're going to be pulling this current pull string out, we want to pull another one in with us in order to have an extra one for next time should something need to get pulled in or something needs to get pulled out and replaced. It's always good to have an extra pull string. This is the good stuff right here. It's not as cheap, but it is so much stronger and nicer to work with, this stuff, compared to something like this crap. All right, let's get this all ready to pull through. And I will tie this up in a manner that the more it gets pulled on, the tighter it will get. Don't have a whole lot to work with here, but we'll be able to get 3. It's not going to be anything crazy strong. But as long as you tie off the tail, this is usually pretty good. And before I give the end a little bit more of a wrap, I will tie on our new string. Okay, we're going to hope this is okay out here and head into the attic and see if we can pull it up. So it has to pull all the way down through the slab, about 3-4 feet underground, and then up the house and into the attic. Even for a cold day, it is still quite hot up here. You can see right here is the pull string going down there beside this black data that we pulled out there. Okay, I'm not going to bore you guys with playing the footage of what happened up there, but the string snapped in the attic, so that really sucks. So we're going to have to fish another string in place now. Yay! This project was never intended to be fun, but now it's definitely not going to be fun. And I'm going to definitely fish it from this end, as the other end is really tight in the attic. So hopefully I can get this in here. Okay, we're 20 feet in, and it's getting a little bit of resistance, so that's probably that next 90 going up. So probably about 16 more feet. Okay, that's probably up now. On the bright side, it's much nicer to pull the wire down here than it is to pull it up there. I thought about just pulling a string, but I think I'll just pull the string and the wire with the tape itself. The tape's stronger, so when I get really angry and start yanking on it really hard, it probably won't snap. Now I have to crawl all the way over here to get the fish stick, or the fish tape. Hopefully it's there. After laying in it, and I mean literally laying in it, I was able to reach all my hand down there and grab it. Okay, this is taped up. I'm going to try and push it down, which means I'm gonna have to lay in there again and try and get the head through the top of the pipe. Okay, I wasn't able to push it down, so we're gonna see if just by luck the head will come through the pipe, but I doubt it will. Yeah, I think that's it right there. Okay, back to the top. Okay, I just crawled in there, like literally face right in it. Like, if you're claustrophobic, you would hate this. I hate this. I'm not claustrophobic because this installation's so damn itchy. I hope it didn't come off. I hope we're gonna end up with a wire and a string to make that work halfway worth it. Halfway is being generous. That sucked. It's tough enough to freaking pull on, so hopefully we're bringing something with us. Oh, okay, I hope that didn't just come off. Oh, I got a bad feeling about this. That got really tough and then a little bit easier. It's still a little bit tough, so it's not completely concerning yet. If it goes from tough to too easy, that's when you get a little worried. And no, I don't have a lube for this, for anyone suggesting it. And then we find out that the fish tape actually sliced through the data. And now we have no data and have to re-pull that. I'm sure it won't happen. It's pretty tough insulation on it. If it was just regular Cat 5e, I'd be more worried, but this... Oh, that Milwaukee electric fish tape sounding real nice right now. Is the string there? Yes, you are. Oh, yes! All things considered, that could have gone worse. I'm gonna cut the string off here. Tie it around this staple that's in here. We can put this guy to rest until next time. I don't know exactly what route this cable's taking, but we'll pull enough for it to go. In case it follows that pipe and then through here and through there. Maybe we should pull a little bit more. Okay. Unfortunately, we are not done yet with the wire pulling, as we still have to take it through the attic, staple it all up, as well as take it down this end of the house, that exterior wall. But we also have a pull string left in that ceiling, so we'll also pull another one in when we pull that guy down there as well. Okay, so that's now pulled over here. So what I'm going to do is now cut the pull string, tie it off to one of these trusses, and I will take the fire alarm cable and unspool it out roughly how much we're going to need to over to that wall. And with it is to follow the same path as this fire alarm wire. That is our NAC circuit, and we have SLC circuit 2. You can see there's a few different things. So if we follow that same path down to the end, that should be best. Now, when the attic space is under 1 meter in height, you can have it lay anywhere you want, just like this Lumex is laying on the ground. So we can just really just drag it over to here, and that's completely fine because it's under 1 meter. It doesn't have to be, actually this isn't technically legal, but it should be on the trusses like that if it's in a space like this that's over 1 meter tall. Okay, so I decided to go the extra mile there and staple it up. This joist there was horrible, but I think it's a better job at the end of the day. So now I'm going to all the way down there, and I don't feel like filming it, so I'll be back once it's done. Okay, I took it all the way down there and then all the way back 20 feet, maybe a little bit more. So here is where I'm going to cut it. So here I did a time-lapse video of running it down. So I ran it down with the rest of the fire alarm cables that were already in the attic, and I stapled it or supported it every other truss, which the trusses are spaced 2 feet apart, and it needs to be supported every 1.5 meters. So if you do the conversion there, you will find that strapping it or supporting it on every other truss is just fine for the support that it needs it would be more than you'd need already by doing it every other tube, but that's what I went with. Down there, and I don't know if you can see that black wire there running all the way down there. It is fully supported, stapled up. We just have to pull it down to the basement. I'll show you guys what we're doing here now. So this is left from our previous install, previous wire pull. So we will tie this on here, over, through, over, through, and I'm also going to pull another string down with it, of course, because I would hate to have to refish this again through this insulated exterior wall. It sucked the first time. I actually snapped off a drill, one of those long drill bits in the wall. It's like a $60 drill bit, gone. This project has cost me a lot of money that I'm not sure if I'm ever gonna recuperate from the YouTube videos. So this is actually a big enough hole if I push the head down like that. I think it'll go. We'll move this light out of the way, so this is all just going to pull through nicely, we hope. Awesome, except we lost the pull string. So as much as part of me wants to say screw it, worry about that next time, I will regret it afterwards. So I'm gonna pull this back up and try and re-pull that pull string. All right, let's do this again. Okay, so over here the string had got all bundled up, but I had enough there. So I've now cut the string off here to leave me some more down there. And I've finished stapling up this wire down to here. So I'm going to now go back downstairs, pull every little last bit that's left here until it stops. And I should actually be done in the attic now, which is awesome. This is so hot up there. I know it looks like a cold day out there, but it is so freaking hot. I'm sweating my ass off. Okay, I'm going to head into the house now. So I need, this is their firelight monitor module. We'll need that out here. But for the house, I need our notifier monitor module. So finished pulling down this wire now, finally. So that looks like that's all we got for the pull string, but that's fine. We'll tie that off now. Okay, this is tied off to this staple here, so I can pull down the rest of this guy. And that's going to be it right there. I'm going to staple this up, kind of like how these other ones are, but it's a little too tight to film at the same time, so I will do this off camera and update you guys once it's done. Okay, that is stapled up now. Now I'm going to enter it into this box. .40 connector. Okay, I'm going to strip back this sheathing now. Hopefully the ripcord will do the job for us here. Let me explain what's happening here. So, we're going to need 4 wires in total. 2 of those are going to go onto this panel's relay, and 2 of them are going to go on to the module. Now the green wire is out of the picture because that is going to be our ground, which we don't really need because either end is bonded. Like this panel is bonded, and so is the other one. So because this box is already bonded, we're not going to need the green. So what I'm going to do is I'm going to separate all these colors here and find which ones I want. So I want to keep the red and the black separate for something else I plan to do in the future with the 2 panels. And as far as the red and the black, this is just for the future. I want to run them down into the panel for something else I plan to do. So since this isn't polarity sensitive, it really doesn't matter what is going out. So I'm going to use the yellow and the orange as my 2 wires coming off of the motor module going to the garage. So now I have an option of which relay do I want to put it on. If I want to put it on the panel's onboard relay or the HVAC shutdown relay. There's advantages to both, I suppose. One advantage of the HVAC shutdown relay of putting it on that is that relay is more programmable, and I can add it to, say, a bypass zone. Say I make zone 99 my disable zone, and I put the bell circuits on it too, so just disabling zone 99 could disable bells and HVAC shutdown as well as times of the other building. Okay, so those are now to here. Now I'm going to bring them down into the panel. That's pulled into there, I can put this back together and actually mount up our monitor module. This is our monitor module here. You can see I printed off a label that I'm going to stick on it. This is the garage alarm monitor. And this one you can see is the ivory colored faceplate, so it doesn't quite match these ones. But after all, this is in not the best lit furnace room, so who really cares? But if I decide I don't like it, I do have some white ones that I can swap it out for. That is all we need for now. Let's go over the installation on this guy. This is our SLC, which we don't want the wires just wrapped up like that. So I'm going to cut them, try and acknowledge this as fast as I can because the dog doesn't really like the trouble signal. Wait for a bunch of... Okay, I think that's all of our invalid replies. I've lost every device on the first floor of the building because this is wired in a loop. After the isolator, it makes one big loop because that's my preferred wiring method. And the preferred wiring method, just in general. These are both our SLC positive. This is our SLC negative. This is our SLC connection on the monitor module. You can see SLC terminal 1 is negative, terminal 2 is positive. That's our negative SLC connection. and this will be our positive SLC connection. You might have been able to see a little spark there. That is our initialization trouble. So now this is our colors going out to the garage to monitor the fire alarm panel out there. So we want to put these on T7 and T6. Polarity doesn't matter on this. If this was a class A circuit, we would return on the A plus and A negative, T9 and T8. Believe I'm hooking this up right. I think I'm on the right side here. Double check in a second. If we're using an end of line resistor in this class B, we want to use T7 and T6. With that, we can fold all of this neatly into the box. Well, neatly enough. And while we still have it open, I will be programming this in as address number 5, I believe. Let's think. I have a list here, but I like to think about it too. We have front door pull station, that's 1. Attic heat detector monitor, that's 2. HVAC shutdown relay, that's 3. And 4 is the back door pull station, so we will set this to 5. 1, 2, 3, 4, 5. And we can now install the cover on it. Screws are always a little tougher the first time because you're actually threading the hole as you go. They don't come threaded. This is the toughest part of the job. It does look a little out of place, I suppose, but not too bad. And now inside the panel, we need to hook up a couple wires here. Okay, so now is what's happening here is we need to bring these wires we just pulled in down over to our relays. I like to minimize the use of zip ties in panels because they can kind of make things a pain, but I'll use a couple of them. I made a mistake here and goofed up. I'm pulling this blue and brown back out. That is going to be what is being used to monitor this panel 4 alarm from the other panel. And I'm going to put it on the HVAC shutdown relay on the other relay that's there. Because there's only one alarm relay here, and I didn't realize on these panels they're not programmable like they are on Firelight panels. So they're stuck what they are from what I understand. And if one is able to be bypassed and the other is just always going to go, I would rather have the supervisory be the bypassable one, and this will be for something else, which I'll do later. So I'm going to pull this up and bring it over and tie it into there. I'll show you what I mean. So I'm going to be tying this into this HVAC relay, which I will relabel the front of it HVAC and garage tie-in. So I want to be on common and normally open. So we'll put one wire here on common. This is common of relay 2. This is referring to. Okay, that's relay 2 common. And I want to be on normally open. Now the resistor for this, the same resistor that is needed on the garage So I'm going to take the common. I have this resistor under the common, and I'm going to chop a little bit off here. Okay, that's spliced on there. So if we meter across 45.5 k ohms, I know you can't see it, so that's what we want. That means that the garage system would be happy. Okay, that's all capped off and insulated, so that's not going to cause any ground faults. As far as the actual physical side of the install, that is everything done for inside of the house. Okay, so my plan here is the same thing. We need a monitor module from this panel, as well as monitoring, as well as connecting to a relay on this panel. If I had a dual monitor module to go right there, that would be great. However, I don't have one, so either way, it's going to require a conduit leaving that box. So what I'm going to do is I'm just going to pipe right down, and I'm going to pipe over, and I'm just going to mount it right here. I think would leave the cleanest looking install. Take this cover off of our sprinkler flow. I'm going to bend up a piece of conduit to go from this top box to the bottom. Alrighty, I've bent up this piece here. So, offset at the top, 90, little kick in, 90, and a poorly executed saddle because I ran out of room to really make the saddle. So we ended up with a kind of terrible saddle. But anyways, let's try and get this in place. If I measured everything right, this should work pretty well here. I'm really not proud of this install. In fact, this is kind of embarrassing. I had to stand this off, and it's finally at least level, but I hate the way this looks. This is atrocious, but, well, we're here with it now. Strip back this entire cable. Okay, so I've got this stripped back to where the only thing left long is the red, black, yellow, and orange. Now, if you remember, the blue and the brown are going to the relay module on the main panel, so that is this garage system monitoring that system. And the orange and the yellow is that system monitoring this system. So the orange and the yellow here need to go and tie into the alarm relay on this panel, and the red and the black are what I left in that other panel that was left for another project down the road. So basically we need to run an SLC to this and get these colors all the way back into our panel out here. So over here, what I'm going to do is I'm going to run this 5 conductor in that pipe along with all of that up This 5 conductor is going to be our SLC. We do run a class A SLC out here. So we might have way extra here. I cut the other colors off down here, but I left them enough room to splice into something should it need to be done down the road. As for our red fire alarm cable, if we pull this much up, that'll be enough. But our other colors, we want to pull all the way through. Crappy part done with here, and try and enter those into the panel. It's going to be a bit of a pain. We got to run it up through this conduit, through there, up into there, then over, and then down. It might be too tight in that conduit going down, but I do have a spare 4 wires there, which I will probably end up using those ones. We'll see. I'll explain where I'm at. Those colors in there, the red, black, and the yellow, orange, are all spliced together. And what they are spliced to is this spare guy running down into the panel. So I couldn't get anything down, and years ago I ran this as a spare. And guys, I gotta be honest with you guys, I hate this system. I like it as far as the system, but trying to work on it, I freaking hate this system. It's gotten ridiculous, and I don't want to say, sorry if I sound a little angry right now. It's just an annoying system to work on. I don't want to hear any comments of, oh, redo the system, re-pull everything. I don't have time in my life to do that right now. I could probably dedicate 2 weeks solid to like rip everything out and redo it, or at least what is salvageable. But the problem is with this system is it started as a conventional system over there. It was moved to a conventional system over here. Then it became an addressable system, but a small basic addressable system. So I just spliced the zones together in a class A manner, and then rooms got added and other spaces got added. And I gotta be honest, the systems became a nightmare. It's not an easy system to work on. There's a lot going on, and even though I'm the one that installed it, it's pretty well slipped my memory. I don't remember every detail now. I'm going to splice our SLC in now. Is going to take place right over here. So we're just adding on to the loop. Very simple what we're doing here. This is our addressable side. I'm going to keep red and black as our supply side. Blue and brown will be the return. So the blue and brown are going to come off of these terminals and go to here, because the supply is going to come from here into here, down through the module, and then out on these and return back. We're just adding on to her. Yeah, sorry about that rant on this system. It's just, there's nothing wrong with the system. It's just, it's like working on an old building that's had a lot of additions. And you may say, well, it's my own system, don't I remember? Honestly, no, I don't. I do not remember what the deal is with this system. Okay, that's that spliced together. Now we'll just gotta tie our returns up and we can reset the system. Actually, no, we can't, because it's still open at the bottom. When in a box with the modules, I like to make the splices to the edge because these modules are fat. Again, I would have liked to have a dual monitor module, but I also would like to get this project done today and be done with it. That's a yibber yabber. Let's put in a monitor module down there. I have me an MMF300. I believe the other module I installed was a FMM1. I don't know, FMM something. Cover. SLC goes here. The colors on this system are wrong, so the colors look a little different in the house system. Red and blue are positive, I'm pretty sure. Yeah, I would have figured it out by now. I would have seen sparks. Not big sparks, just little SLC sparks. And the panels start beeping. You shorted out my SLC, you mother... No sparks. That's always nice. No beeping yet either. Mind you, it is already in trouble, so we should probably reset it, shouldn't we? I know your SLC is open, but here you go. I reset you now. Shut up! Go. Again, I'm not proud of this install down here. I'm not proud of this whole video. I don't like this whole thing. Let me know if in the comments if this thing's any good. This is one of those videos that I film and not upload, but I put too much time into this one. I'm going to upload it. What are we going to set it to? I think you can set this to 5. I think there's an open spot at 5 on this system. Because for some reason... I knew this at the time. I knew that modules and monitor and modules and detectors were separate, but for some reason I set all my detectors like, I think I did module like up to 4 for pull stations, and then 5, 6, 7, 8 for detectors, and then went back to like 9, 10, 11, 12 for modules. Why I did that, I don't know, because I knew that it was different and I could. I think that was my idea of making it simpler. I believe the trouble relay is not programmable on this one. Or maybe it's the alarm relay. Let me check right now, actually, because some of the relays aren't programmable on this one. I believe 2 of them are, but 1 isn't. So I believe we go to programming. All the zeros, man. All of them. That one too. And then we will go to system setup. Relays. Relay 1, type, alarm. That's relay 2. Okay, so, I don't know why I shouldn't even be on that one. It goes 3, 1, 2, because that makes sense. 3, 1, okay, what's 2? Sorry, relay 3. Oh, that one's programmable. Relay 3. We are going to set that to alarm because this relay needs the trip when this system goes into alarm to put the other system into supervisory. Okay, you are now an alarm relay. So I was right, guys. This first relay, the trouble one, is not programmable. Now we have to program both of these panels. So while we're here, let's start with this one. We are going to go to programming, 0, 0, all zeros, and I'm going to go to point program. This is going to be a module, and I'm going to add a module, and I'm going to add module number 5. Actually, before this, I want to make sure there is no monitor. There is no number 5. So let's do read status point 2 is module, and if it goes to a lower or higher number, I believe it'll go lower, then I know it's not there. Yes, see, it went to number 4, which is garage bay pull. That way I know we are okay. Now we'll go to programming. Point module add 005. This is a monitor module. And now that that's added, we have to go to edit, number 3, number 5. And we can leave this at zone 0 because we don't need it activating anything. Enabled type monitor, but we want this to be see what it gives us here. Supervisory AR, meaning it'll go back by itself. Pre-signal, no, it's not going to work for that anyways. Yes, we want it on walk test. We don't need a zone assignment. We will give it a description though. How do you do one of these again? Yes, okay. We will call this okay, that works for now. Fire alarm in-house. Fire alarm in-house. Okay, so that should be it for out here. Our new module is now communicating. At this point, the house will activate this building, but this building will not activate the house. So let's go program up the house panel. All right, let's program up Mr. Notifier. Programming. All zeros for our password again, just more of them. And we'll go basic program, and we'll run an auto program for it to find this new device. Okay, so there we go. So right now it's a monitor, pull station, smoke conventional, smoke detector, water flow, audio system, equipment monitor, hold up, RF supervisory, latch supervisory, track supervisory. I think that's what we want. We'll call this and we'll call this building B. So I believe this is set up the way we want it here. I don't need it activating any zones, so I think we'll just leave it as this. See, this is now pulling, which is good. I think now we're pretty much at the testing point of things, other than labeling a couple things, but yeah. We seem to have a trouble. I'm guessing it's that resistor. Nope. Oh, it is, okay. Open. I think it is what we did with that resistor there. Maybe I was supposed to go between normally closed and common. I'll see if that's the fix since I've done one of these, but I know there's a way of not just going directly across, which will make it supervised for tamper, basically, if that makes sense. I don't think it's latching, but maybe. It's happy now. So is what we're going to do is we're going to set off this house system and hopefully put the garage system into supervisory. I'm just going to pull this pull station down here and we're going to keep it brief. Okay, pull station, laundry / back exit. We've put the system into full alarm. So the garage system should now be in supervisory. Fire alarm in-house. I don't want to silence it though. I want to test the resetting part of it. I know this relay does take a little while to reset. But we'll reset the system in here. And the garage system won't go back to normal until that resets. But in the meantime, let's head out to the garage and we'll know when it resets, because our supervisory should go away in here. Dude, that relay does take a bit to reset. I know it like waits for the panel to reset and then it takes a little bit after. Oh, you can see this module is active. So there you go. Oh, and there you go. Okay, now I'm going to set this system off. Supervisory garage fire alarm building B. Okay. Okay, let's reset the fire alarm out here now. And it sounds like our supervisory is gone. Yes, it is, all back to normal. I'd like to edit the name of it now that I know it all works just a little bit. Modify point module. What is this, number 5? Oh, that's funny. We actually ended up at the same address. Number 5 on this system and number 5 in the garage system for the supervisory monitor of the other one's system. That's pretty cool. For that to happen, I knew it would. Fire. I just want it to be a little more obvious what is going on. Fire alarm. In fire alarm in garage building B. Okay, that is working absolutely as intended. Okay, I've slapped the label on there, house alarm monitor, just like the house says, garage alarm monitor. So I like that. As much as I don't like this little install down here, it did work out, and everything did work out. Guys, I've got a bunch of cleanup work to do, and as far as the actual install, that's done. That is it. So I'm happy with this. This works good. I like getting the alarm in the house, like knowing about it out here. Like if I was sitting out here, I'm obviously not going to hear the house. Same vice versa. So it's not like deafening, like holy crap, the area you're in is actually has a fire alarm event, you need to get out, but you still want to know when the other building on the property is experiencing a fire alarm. So I like that, especially for anyone in the house. They don't need to be freaking out about it, but I mean, it's still going to grab your attention, and you're going to look at the annunciator and say, oh, garage, fire alarm in garage, okay, that should be investigated. So I'm happy. It's the perfect balance of like letting you know versus not being over annoying. And the biggest thing is if a fire alarm happens in either building, you don't have to go to the other building to reset it. Sure, it will be in Supervisory, but you don't have to worry about it. You can just reset your alarm and it'll go away in the other building. So that's nice. So yeah, that's going to do it for this video. If you did enjoy it, make sure to give it a thumbs up. If you do have any comments or questions, feel free to leave those down below. And if you do enjoy my channel, make sure to subscribe. Also, if you are interested, I do have an Instagram account at Pickle700 for bonus content and content posted earlier than you'd see it on the YouTube channel. That sort of thing. Alrighty guys, that's going to do it. Thanks for watching.